Yeah.
Hello viewers, welcome to our today's tutorial. In this video I want to show you how you can model any type of steel structure here in Proter structure. How you can model, you can load or perform loadings, you can analyze, design, and then get all your detailed drawings either in Proter steel or in Proter details. So this video is basically for beginners or those who want to have a deeper knowledge in Proter structure or Proter steel. But before I continue, I want to appeal to you, the viewers. If it is the first time you're coming across this channel, you can support us by subscribing to this channel, liking it, and sharing it with friends. So without wasting time, let's get into it. So if you open your Proter structure 2022, as you can see I'm using 2022, and if you also need this version of Proter structure, you can chat me on the number in the description of this video so that you can get the Proter structure 2022, put the Proter steel, the Proter details, and the normal Proter structure, all they're perfectly working well. So when you open it, you can see it's a licensed version. You can see it's licensed, expiring on 2024. So I can just go on new project and type the name. So the name of this project is Trusses. So you can use shift and space Truss design. So the building is a truss. So I want to select a code. So you select the code that is peculiar to your region or your country. So I am in Nigeria, and the code Nigeria is not there, so the one nearest to me is South Africa. I'm using South Africa BS 8110, and I will say OK. So you give it time to process. Okay, and it processed and open like this. The first thing now you do is to create your axis, and if you look at it here, you can see your axis. So you click on axis, right click, and use orthogonal axis generator. So you click on it, and when it turns like this, you just drop it inside. So this dialog box comes out. So what I want you to know, take note of this. Your direction 1 axis is your horizontal direction, and your direction 2 axis is your vertical direction. Please take note of that. So now in my horizontal direction, based on the architectural drawing or based on how I want to position my columns, I want to position that at interval of 5 meters, but then the length of this building is 30 meters. So 5 meters, and I have them in 6 places. So if the distance is not the same, let's say we have 5 meters, we have 4 meters, then you have to be entering the distances. You enter this, you give space, you enter, you give space. Okay, then the width is 10 meters. 10 meters, then it's just in 2 places. So when you're done, you click OK. here. So this is what you have. As you can see, from in your horizontal direction we have 5 meter, 5 meter, 5 meter, 5 meter, 5 meter, 5 meter, and total the length from here to here is 30 meters. 1 2 3 4 5 6, exactly as we entered in our direction. And from here to here is 10 meter, and this 1 2. So this is exactly how we want our axis to be arranged. So now the next thing we do is to set our levels. So to do that, you go to building setout, go to stories, from stories go to edit stories. You click on edit story. Our steel column is starting on the natural ground level, just it's more offset. There's going to be no concrete column. So, and then the height is 4 meters. 4 meters. And you click here, you change. And the foundation, from down we have a foundation, and the foundation is 1100. You can leave it like that. And you click OK. Okay, then before then, okay, let's do it again. Edit story. Okay, it's 4 meter. And then we can come here, this structure, reinforced concrete. You can click and then say steel. Called our work is steel, the steel structure. So you click OK. So now you have done with our axis, and we have done with setting the levels, like the height of our building. So the next thing we do is to start modeling. And modeling, we go to modeling. And since it's a steel structure, this tab from here, column, wall, all these, they are concrete. And then we come here, steel members. This is where you get all your steel members. So our is a steel members. So we go to steel column, make a column, and you zoom. So when the columns open, you click on this. You can select different properties of the column. Click on this icon, where it shows a symbol of a steel column. Click on it. Now you have the option to select different types of shapes. These are DS shapes. So you have Euro, you can have American, you have Singapore. So you select the one that is peculiar to your country. So I'm going to use the BS shape. So come to universal column. I'm going to use 203 by 203 by 46. These are trial sections. So we'll try with this, and when this will not pass, then we go to the next one until we get the one that is that will pass for this building. So if this has passed, sometimes it will pass, but it will be underutilized. So in that case we can go lower, we can pick a lower section. Because I will explain all of this as we proceed in this video. Okay, so now when you select 203 by 203, you select it, then you change direction. This change direction here, you click on this arrow, it will rotate it, then you click OK. So now you can drop it at the intersection of your grids. Okay, you can drop it like this, or you want to be faster, you can hold and drop. You can see it has automatically inserted. So you can drag this and then insert it. So it will automatically insert at the intersection of grids. So when this is done, let's look at it in 3D. Go to view, right click, and then select your 3D. So now we have the two views here, plan view, and then we have the 3D, so you can navigate in it to see what you are doing. So now the next thing we do is to add our trusses. So you go to steel member, go to truss. From here you pick a point. Let's pick this point, and then you pick the second point where your truss is going to end. I'm going to end on this column. Click. Just give it time. Okay, so when it opens like this, by default Proter structure has these 6 different types of trusses. As you can see, it has a curve, then it has this slant, and then it has this. These are the types of trusses that Proter. So whichever one you select, you have different types. You have different types that you can select from, just like this. And in case if what the type of truss you want to model is not here, you can model in AutoCAD or in other modeling software and save it as a DXF. Then you can import it here and assign your properties here in Proter structure. So it gives you room to model exactly how you want to model it. For the sake of this video, I'm going to use this. I'm selecting the first, and then when you select this, you look at this, the whole picture of it is here, and then the properties of this truss are here. So when you come here, top code, you say top code, that means you want this top code to be at the top code. So divide diagonals. Yes, I want my diagonal to be divided. I like taking this, and then inverted truss. You want this to be down. You want your apex, this height, to be down and this one to be up. You can invert it. In some cases you may want to do something like that, but in this case I want my apex to be up the way it is. I'm not going to invert. And then left vertical offset. Sometimes you may want from where it's going to support, let this go up. You can offset it by that distance you want. You can do it in the left. There is left vertical, left. That is the left side of your screen is your left, and the right side of your screen is your right. So left vertical, we put it to offset it here, or to offset the other way. Then we have for this lecture, I'm not going to offset it. It's going to be exactly at the support. It's going to be entirely in contact with the support. So we have a cantilever length. I'm going to put a cantilever of 500 on the left. You can see it has moved. Have a cantilever of 500. Click here. You can see it has a cantilever of 500 by the right. So you can see your support is here, and here is the cantilever. Okay, so we model joint as fixed. Yes, I want this joint to be modeled as fixed. We don't want to uncheck it. Okay, then the apex height from here to here is our apex height, and I want this height to be 1500. Okay, that is too small. It's okay. Let me maintain the 2 meter is 2000. Okay, it's your apex height. Then this, say, place apex symmetrical. Yes, I'll take that. Enter the heel. Enter the left heel B. So now if you want the distance, left heel is this side. If you want the angle, this inclination angle, then you can tick this, and then left heel angle, you can adjust the angle here. Let's say you can this angle, I'm going to give it like 10. Let's see what we have. Okay, you can see it has gone too much, so let me take it, let me increase this to 7. Okay, 7 2 is say 5. Okay, no, let's say 8. Okay, have something like this. 8 is good. So I can come to enter right, the same thing you do at the right. You tick this and then you enter 8. Okay, so you have it just like this. Okay, so now the spans, the total length from here to here is 20 meter. The number of spans at the left, from the apex to here, is the left. The number of spans is what? 1 2 3, which you have there, and then from the apex to this other we'll have 1 2 3. So we'll have 3 at the left and 3 at the right. So but in this case I want to have 4. I also want to have 4 here. So when you click here, you see you have something like this, and then the interval is 2,500. If this is too wide, sometimes if your span of your building is wide, then the closer your spacing, the stronger your truss. So this I want to make it 2. I want to make it let's say 5. I want to make it 5. Okay, and we can have 2 meter just like this. Okay, so you say 2 times 5 will give you 10 meter. Okay, then the next thing we do is your top and bottom chord. So your top chord extension, I want my top chord to extend a bit. Let's extend by 500. We'll click here and see the extension, and I want the right also to extend by 500. You click here and then it extends by 500. Okay, so this, you want to delete the first member, you can delete, but I want to leave it. Okay, so when you're done, you just say okay. Okay, your truss has inserted just like this, and the next thing you do is just to drop at those points where you have column. Drop at those points that you have column. Drop at those points and you have column. Okay, so this is what you have. Okay, so now the next thing you do is to insert your lines on this. Let's go to steel structure. But before we insert our lines, let's insert our braces. We insert our winged braces, and then our horizontal braces, and then our vertical braces. So go to braces, pick brace, and select the member 1, select the second member. Okay, your brace has come this way. So we have the total height of 4 meters. If you want, you will have 2 counts of your brace. And then right here 2. It's 2. Okay, I have 2 counts, 1 2, just like this. Then okay, then you can you can select the type, the profile, which is angle 90 by 90. If you don't like this, you can change to other section, but I'm going with the default. So I'm going with angle 90 by 90 as my this. So we can have something like this. Okay, so we can have one in the middle. Okay, and then you can have one here at the edge. Okay. Okay. So when you are done with this, you can see do the same thing this way. You can see do the same thing this way. You can see do the same thing. Okay. Oh. Okay. You can see do the same thing here to here. Okay, so this is how you put your, and then for the roof, you can click here to here. So for your roof, you can see we have two types. We have braces up and braces down. So you can come to here. I only want my braces at the top chord and not at the bottom. So I can come here and then remove this and say 0. Okay, so I can have only at the top. At the top I have 2 counts. If you want to add more, you will have 3 counts. So you can still have 3 or 4 counts. Okay, 3 counts here. Here too, we have 3 counts. Okay, you have something like this. So say okay. So this is what you have. Okay, and you select this one. Same properties. Okay, right click, open properties. Just delete this. Delete this. Have here 0. Okay, and then have here 3 counts. Have here 3 counts. Okay, so you can have it like this. Then you have the second one here to here. So you do the same. 3 counts. Delete this. The bottom code, you don't need it. Just delete 0. Okay. So can come here and type 3. Okay. So this is what you have. Then the next thing you now do is to insert your polylines. Come to polylines. Select polyline, then select first member and select the last member. And you can give it time. Okay, let's do it again. Modeling, polyline, pick this and pick this. Okay, so your polyline has come. So polyline, you can start to change your profile. Click here and change the profile that you want. Okay, on section, you say on section, your polyline is going to be at the top. But in case you want it to align at the bottom, you can see it's going down. Which in case I want it to be on top, I'll leave at the section to be on top of my polylines be on top of my trusses. Okay, then placement, I want the top chord should be the one that my polylines will be placed on. Okay, you want your polyline to be placed at bottom chord, you select this and it will be placed at your bottom chord. I want it to place at top chord. That's come on. And then generation methods, I want this to be by spacing. Okay, spacing. Let me control the spacings on my polyline. But if you leave it by if you leave it by joints, that means it will be placed at those joints, these joints, just like this. So I want it by spacing. Okay, and I'll type my spacing 1200. I'm going to use a long span. Okay, then delete first member. So this member, if you look at it and let's say it's too close or it's outside, you can delete it. But in this case, it's okay. I want to leave it, and then delete last member. So I want to leave them. And then you also have left cantilever length. Okay, I want to have a projection. Left cantilever length, they have projection of 500. I want to have a projection of 500. Okay, you can see this projection is projecting, and it's projecting this way. Then cap between polylines, so I'm going to leave it at 0, 0, and then okay. So this is basically okay. I will say okay. Okay, so your polylines has been inserted just like this. The next thing we do now is to put our cladding. Cladding is how you put, and then we assign our loads. So you go to C, go to cladding. This cladding, you pick it and you select this. Okay, then simply just click OK. Simply click OK to assign your cladding. Your claddings are being inserted just like this. So now we are going to load our structure. I want to load it and set it for analysis. So to perform our loadings, all our loadings are going to be applied on the cladding as area load, and the area load will transfer to the frame. So we'll select our cladding and say edit loads. Okay, they say load cases must be defined before load assignment. Would you like to define load cases? Now I say yes. Okay, so you can go to loading generator. And create different combinations for steel. Yes, you want to have wind, you come here and take wind, but in this case I'm not considering wind, but it's just 4 meter. Okay, say okay, then generate. Okay, so it will automatically take you to where you can assign your loadings, and the load is full uniform area load. So you select this. Okay, so based on your calculation, based on your estimation calculation of the roof members, and then you say the live load that will be applied on this roof, and you enter the values. A G is your dead load, enter your G, and the load gravity is the load direction is gravity. Gravity is want to be acting downward. Okay, if it's in the X direction or Y direction, you can select, but in this case it's acting downward, and the size of the load is 0.23. I'm going to use 0.23. Okay, so when you put your value, the next thing is select all this, and you can see your load is being applied just like that. So you go to the next, your Q, live load, and we'll see maintain this 0.23. so you can see, come here and select all of this. My load is applied successfully. So click OK. So I have not considered wind load. I have not defined the wind load combination, so is it. So the next thing we do now is to run our analysis and see if our members pass analysis or not. So we go to analysis. We have building setup, modeling, we have done loading, and now we are going to analysis. Analysis, go to building analysis. Okay, so now you set your parameters based on how you want to. Don't have concrete members. You can edit material. Okay, I want to leave my steel column as this, steel beams, these trusses. Okay, I'm going to leave it as default. I'll click OK. Then I can go to so if you go to design center, I'll give it time. Okay, design center can take you to where you can carry out your individual settings. It's mostly for concrete structures and steel structures. So I'm going to that. Then go to analysis. You can run a building check to see if there's any error. If there are places that you have two columns in one place or intersection of axis, then you can run your building check to find out. Okay, you can start. Okay, as you can see, there's no arrow, no intersection of column, no columns in two columns in one place, no intersection of beams and columns. Okay, so when you check, you say okay, you close this, and then you run your analysis. So it is T, so select T, run analysis. If in case you need this software, Proter Structure 2022, you chat me on the number on this below the description of this video. I will give you the software. Proter Steel is perfectly working well. Proter Detail is working well, and then the general Proter. So you're going to enjoy it. Okay, it's still calculating, still member design check, it's checking. So with the load that we have used, after we check our results, so we see the members that pass and the members that failed. Okay. See member check design, affirming truss check design. Okay, now it's done. So it took 2 minutes 20 seconds to run the analysis, and you can see direction 1, relative story drift satisfied, this everything satisfied. So click OK. So you close. So now you can go to display, you can go to visual interrogation to see the color codes of your design. Go to design status. Okay, you can see the members that pass are in green and the members that fade can see them. Okay, you can see everything has passed. There's no failure. Everything has passed. Okay. Okay, but then before I take it to Proter steel, I want to put my girts all around, and then have a place that is door. I'll show you how you can create an opening for door using your girts. So we see, go to modeling, go to steel. The analysis is going to be done again. So you go to girts, pick the first one and pick the last one. Okay, you can also have the section of your girts. You can use spacing. So I'm going to use the default. So I can click OK. I say yes, go ahead. I want to run analysis again. Okay, you can have this, because with this you can have your claddings attached to it, just like this. Okay. Okay. So I can have my girts from here to here. Okay, I can have it. I can have it from here to here. I can say okay. So here I have a door. So I can have here to here. Then I can go down and say bottom member offset. Okay, so this is the bottom member. I want to offset it up a distance of 2 meters or 2,100. That is the height of door. Say okay. You can see this is now for entrance, for allowance for entrance. Okay, then I can pick here to here. Okay, then take it back to 200. It is start at 200. Here there is no door, so you can have it like this. Okay, you can have this to the end. Okay, so this is how you can create your door level or your door entrance using your girts. Okay, so if you want, you can carve here to here 20 meters. We can introduce a column to support it. Okay, you can have from here to here. Okay, so here let's also have a door here. So let me delete this. Escape. Let me delete this and insert again. I want to have a door here. So go to steel, go to girts, pick here and pick here. Go to modeling. Let's do it again. Pick girts, pick here and pick here. Okay, so we give it 2,000. Okay, let's say 3,000. So this 3,000. Okay, so let's have our door here as 3,000. Okay, so we can pick here to here. So 3,000. We can have it here as 200. Take it back. Okay, have like this, and then pick from here to here 200. Okay, so we come to this door and take it up a bit, take it up, properties, and then take also here to 3,000. The same thing with what is on the other side. Okay, so this is This is it. So now you can run the analysis again. Go to analysis, build the analysis, go to analysis, go here, it's already checked. So you can take this and you can run your analysis. Okay, so analysis has been done, just like this. So you click OK, you click, you close, and also you view it and see. You can see some of our members have fade. Okay, this has fade. So let's just look at it, the one that fade. Okay, these are truss fade, others passed. Okay, let's go to design. In design, you would look at the members one by one. Let's check our column, still column. You can see our still column pass, and the utilization ratio, you can see 0.1, which is less than 1. Okay, so with this, either if this is underutilized, you can select a lower size of column, 205, 230 by 230, 203 by 203, which is underutilized. You can select a lower one, 152, and then you try it and see your utilization ratio until you have something 0.7, 0.5. okay, for that range is good. Okay, so you can close this and you can check your steel beam. Don't have steel beam, check your braces. Okay, all braces passed. This one I showing red and just slenderness, slightly showing slenderness. Okay, it's not a problem. Okay, and you can go to your pole lines. See all your pole lines pass. Utilization ratio 0.3. Okay. Then go to your trusses. Okay, this is too fade. So you can go here, check why you put the bottom code. Okay. Go here, select on it, and then see why it has fade. It is 1.158. The utilization ratio 158, and it's supposed not to be more than 1. That means you can increase it slightly to have what we want. You can change this section. You can increase the thickness of our angles. Go to double angle. Go to angles. Okay, let's pick 15. Okay. You can see all has passed. So you can say okay, and utilization ratio is 0.77, which is very okay. Okay, you can say okay. Then you can come here, see do the same. Utilization ratio 1.174. This it should not be more than 1. If it's more than 1, it will fail. So you go to change section, you go to here, and then you increase it to 15. Okay. These two has passed, and I say okay. So all our trusses has passed. Okay, close it, and then let's check our gates. So the gates too passed. So you can see all our members now passed. Everything is now green. Okay, this one has passed, but it's just graphics. So now we are going to export this to Proter still for our detailing. So to do that, go to drawings and reports, drawings and report. If it's a steel work, you go to Proter steel. If it's a concrete work, you have concrete parts. You can also export it to Proter details. So we can just click on Proter steel and give it time to load. Okay, Proter steel is loading. Still loading, give it time to load. Okay, so when it's loading, you can see 816 profiles successfully imported. So you can close this, and then you can have your structure here in Proter steel. Okay, so in Proter steel, to rotate freely, you press F9 on your keyboard, F9 on keyboard, and you pick a point. So this will allow you to rotate freely, just like this. You can rotate it freely now. Okay, so as we are in Proter steel, we will quickly be running our connection designs. So I will show you, I will be using IntelliConnect. I will not be using the manual connection. So I will do to reduce the time of this video. So I can just select on all, and then right click and say IntelliConnect. First I want to connect all my polylines. I want to run all my polyline connections. So these are different types of polylines, or arrangement of polyline connections. So I want to use angle type, and then you can invert it, and reverse, take it the other way. Okay, we can use auto. The software can determine which of them to select for you. Okay, you can go to next, then you can apply the gap. We can put 3 millimeters. Better leave it as default. Then you can run. Okay, give it time. Okay, you can see all I've done. You can close this, zoom closer, and you can see your connection, your polyline connection, polyline to polyline connection. You can see. So you can use F9, click here and turn it, so you can rotate it just like this to take a look at it. So this is your polyline connections. So when you're done with this, you select all once again, and right click and go to IntelliConnect, and now you say get connections. Okay, I also want to use angle. Okay, I want to use reverse, run. Okay, it's running. Okay, it's done. It's finished. If this IntelliConnect is good because it saves you time of doing this one by one. Proter Structure 2018, it has all these components, but you can be doing it one by one. Okay, you can see this has connected connection or connections just like that. Okay, then you can also select this, then run your Trusses connection. Okay, we also have sag rod connections. You can connect all the sag rods on your polylines. So this is how you use IntelliConnect. It's very fast, and when you have a complex work, this is good in doing. So we're done with your, go to IntelliConnect again and run your truss connection. Where is truss? Okay, bracing connections. Bracing connection. Bracing, you can set the gusset plate. What is 8 millimeter thickness on my plate, gusset plate. So it's going to connect both the horizontal braces and then the vertical braces. Okay. This is done. Okay, you close it. You can see it starts done our braces connection just like this. Okay, so we select it again and we run our trusses connection. Teleconnect, create truss connections. Gusset plates, those have 8. Then you run. Okay, so when you're done with all your connection, then the next thing we'll do now is to perform our numbering to create our drawings, our detailed drawings. Before perform our detailed drawings, I also want to show you how you can have your details, your detailing items. You can use this icon. Detailing icon is very important. Okay. Some are connected, some will not connect. So the one that will not connect, you either connect or you select the one that connect to print, get your detailed drawings. So you can see all have connected. Okay, so now I want to show you how you can get your details, your detailing. You use this detailing icon. Okay, let's say I want to show the detailed view of how the connection between this bottom cord and all these braces have been connected. I want to show a detail of how they are connected. So you can have maybe another complex joint, then you want to show detail. So you look at the complex joint within your model and I want to have your detail view. So let's say in this case I'm going to have this. I can select this and then select the detail. Then I'll give it a name. You can say this is detail A. So you can add. So I add the name, it's already here. So now say select objects. Object that you want them to be included in the view. In this, I want this member to be shown. I want this member. I want this member. I want this member. So you finish, you right click, and this are being inserted just like that. So this box has been inserted. So now on this box you tick the views that you want to see from here. You can either add the 3D view, you can tick the bottom, you can tick the back, you can tick the right. So that means it can show you the back, the right, the front, the left, and the bottom, and can show you the 3D as all these views that we have here can show you. So we are done with this. You can simply now say close. So now when you go to our detailing, I can show you how you can get this your detail view. You can have as many as possible detail views. Any places that you see that it is not too clear, you need to show clarification on how the connection is done, you can have that box. So when you go to your detailing, you can click on it and have a detailed view of that. The essence of your detailing is for your drawing to be simplified. Okay. So when you're done with that, the next thing you do now is to generate all your drawings, perform your numbering, select all. Okay, go to drawings, perform numberings. Okay, can say yes, apply numbering. Okay, numbering completed. You can say okay. You can close this. Next thing I want to do is I always like to run my class check. Go to tools, check class check, and run. Okay, this has been done. And then we forgot to insert our foundations, our bases. So select the whole building. Okay, let's run our interconnect. Let's put our create column beam connection now. Create foundation. Okay, so foundation is not here. We insert it. Okay, create base plate connection. This one. We'll select this. I'll say run. So it will select the places that needs base plates and it will insert. Okay. So we have up to 14 places. It has all been done. Okay, so now we have our base plate. Our base plate inserted just like this. Then we can reperform our numbering. Go to drawings and reports. Perform numbering. Let's run it again. Okay, can close and still run the class check to our class check resources. Okay, so now you can select all and generate your assembly and parts drawings. Go to drawings, you can have create drawings, create assembly drawings, and click. So now it's generating all our assembly drawings. When assembly drawings is completed, then you can still go to drawings and generate all your parts drawings, or you can select some parts that you want to show in your details, and then it will generate the parts drawings for you. Then you also generate your general arrangement, your GA arrangement drawings. So once we are done with our GAs, then that will be the end of this video. If you enjoy what you have seen, if you enjoy this video, make sure you subscribe to this channel and you give it a thumbs up and share it with others. Okay, so our assembly drawings are almost okay. So when it has been done, to view our assembly drawings, you can go to Drawings Manager, double click on it, and our assembly drawings, just click on any one. Okay, assembly drawings have been created just like this. So this is your assembly. You can pick any of the parts. there are many. It's not everything you're going to print out. Not everything you're going to print. You just select the ones you need that are vital to your work. Select it and then you print it like this one. UK 890 by 90 by 8, part 87. Then this is this is our braces that we used. So this is it. So this is how you get all your assembly drawings. So when you're done, you can close this. The one you can not save, or the one you can save it. You can close this. Okay, and come back here and then go back to the same process and come to your drawings and then create all your parts drawings. It is in the same way you create your assembly drawings. But then now I want to show you quickly on how you can have your GA drawings and then have your detail box, your detail views. So to have our GA drawings, we go to drawings and view. So story 1. Okay, let's push this to. Okay, so this is our plan view. Our plan, you want to have your plan view, you can have this. That's your roof level. Come to view, come to story 1. Now come to foundation. You can have this your foundation with your base plates. Okay, you can have them like this. This is your foundation plan. Then you can just keep dimensions. Okay, now I want to have a view along grid A. This is grid A. I want to have a view along grid A. You go to view and you say create view by 2 points. Okay, so you come here, select here, then you go here, make sure it's not, you select here. Okay, so this is our view. Okay, so now you can double click here and then call this view at grid A. So you can have different views as much as you want. You can say okay. So you can go at any other place at the other grid and select the 2 points that you want to have your view, and then you can save them. So all the views you save will be aligned here. You can see view at grid A. Okay, so now, so how do we now take this to our drawing? Okay, so to do that, let's go to our drawings. Let's go to F, then let's pick any of our assembly drawings. So we can pick this. Let's pick one. Okay, so when this is open, you have it like this. Okay, this is your other assembly drawing. You can see these are your quantities that are neatly done. Okay, so now for you to have our GA drawings right here, you can just come to this view, right click and say create viewport. Okay, you can see this is already here. Okay, this is already here. So now you can just go to your, this is an annotation here, and you open, you just right click there, it will open to actual parts number and the profile name. Those are the the things that you want them to show. You say okay. So when you click on this, you click here, it shows you the name. When you click on this, you click here, it shows you the name. Okay, so if you highlight everything, if you highlight this, so you highlight all this. You don't want to highlight grid, you highlight all this, and you point here to show you all the names. Okay, then at this point you can select the ones you want to have their name shown and the ones you don't want to have their name shown, or you can do it one by one. Okay, so this is basically how you do it. And then you also want to bring your 3D great viewport, then your 3D drawing is already here. Of course, if this is not big enough, you can scale it. You can export this to AutoCAD and have it like this. So now our section box, look at this box here. When you want to click here, all your section box will be created. So you can click here. Okay, and you can see those are our detail section, front, this detail left. So all our drawings are created just like this. Our drawings are created just like this. Okay, so you can see all those your detailed views. So you pick the ones you feel are relevant to you. You can pick this, and then you can delete the rest. So it shows you the detail. See, it shows you the detail at this point. So this is your detail A. So it's showing your detail A, and these are the views for the detail A. If you like this video, don't forget to subscribe. As you can see, this is a new channel, and it's the only favor you can do for us is to subscribe, you like, and then you share with others so that this channel can grow. Okay, so now you can still come to F, your foundation, click let you put, and then you have your foundation just here. Okay, so if you want to have dimensions, just go to dimensions, go horizontal. You want to pick from here, you can pick from here. Horizontal dimension, you pick from here, and you pick from here. Okay, and you pick here, and then you're gonna pick here. Okay, and then drop here. You can see this 10 meter. So if you want to have a vertical dimension, you can come to dimension. Instead, now you pick vertical. Those of you that are conversant with Tekla, it's almost the same. So you pick from here, and then you pick from here, and then you say you come to the apex here, and you pick, and you come and you right click to drop. So you have 4 meter, and here you have 2 meter, just like this. So with this, you can export this to AutoCAD and rearrange your drawings on how you want them to be and present it, and that is all. You charge your money as an engineer and you deliver your work professionally. So thank you for watching, and stay tuned for more of advanced videos like this in my subsequent videos.